Thank you. Hello and welcome to Data Structures and Algorithms in Python. This is an online certification course being conducted by Jovian. Today we're on Lesson 6, Python Interview Tips, Tricks, and Practical Advice. This is the final lesson of this course, so I hope you're excited. My name is Akash and I'm your instructor. You can find me on @AkashNS. If you've been following along with this course and you have been working on the assignments, and if you complete a course project as well, then you can earn a certificate of accomplishment for the course, which you can find on your Jovian profile and also add to LinkedIn or download as PDF. So let's get started. First thing we'll do is go to the course website, pythondsa.com. So this is the course website, pythondsa.com. This is where you'll find all the information about the course. You can watch all the previous lessons, lessons 1 through 5, and you can also check out the previous assignments, assignment 1, 2, 3, and you have the course project as well. Let's open up lesson 6. Now on lesson 6, you will be able to find a video recording of the video you're watching right now. And here is the code that we will look at today. So today we'll do something different. We will simulate the experience of being in an interview. So while we have given you a problem solving template, and we recommend that you follow this template for any project or any notebook that you work on, any coding problem that you work on. And here on the problem solving template, we also have a method, something that we have been applying throughout this course to different kinds of problems, different kinds of data structures and algorithms. But in an interview, obviously you will not have this template. So we'll see how to apply this method during an interview. And before we do that, let's revise the method so that we can recall it from memory when we are working on the interview problem. So here is the systematic strategy that we have been applying so far for solving problems. And do check out the previous lessons if you haven't seen them for examples of how to apply it in detail. So the step 1 is to state the problem clearly in your own words and identify the input and output format. And then the second step is to come up with some example inputs and outputs and try to cover all the edge cases that you can think of. So you want to think of all the possible scenarios, and that will help you write your code properly. Then step 3 is to come up with a correct solution for the problem and state that solution in plain English. And then step 4 is to implement the solution and test it using some example inputs. So this is important while you're practicing, but initially when you come up with a correct solution, it will be a simple solution, what is often called a brute force solution. And in an interview setting, you may not have the time to implement it from scratch. So you may skip if the brute force solution is too straightforward. Then step 5 is to analyze the algorithm's complexity and identify any inefficiencies in the algorithm. So what you can do in an interview is come up with a correct solution and describe it to the interviewer, and then analyze its complexity directly and start identifying inefficiencies, and then move on to apply the right technique to overcome the inefficiency. So this is where you need to identify which one of the techniques that you've learned in this course do you need to apply. Is this a binary search problem? Is this a divide and conquer problem? Is this related to binary search trees? Is this something that you can solve in a similar way you'd solve sorting? Is it important to look at the worst case or average case complexity? Is this a graph problem, or is this a recursion, or is this a dynamic programming or a memoization problem? So all of these things are something that you have to think about. And as you practice more and more problems, so for each of the lessons, if you try and practice about 5 to 10 problems, then you will start to recognize these patterns. And when you're on step 6, when you're trying to come up with the right technique to overcome the inefficiency, the ideas will automatically come to you. So practice is very important to succeed in step 6. And once we have determined how to overcome the inefficiency through the right data structure or algorithm, then we state that solution, implement it, analyze the complexity, right? So this is how a coding assessment or an interview should proceed for you. And let's pick up a coding problem and let's go from there. So here we have a coding problem, Python subarray with the given sum. and we'll read the problem. But before that, you can see that here this notebook is fairly empty. And what we're trying to do is we're trying to simulate the situation where you are on a call with somebody and they are interviewing you. And typically they would be using some platform like a Collab Edit, or maybe a platform where you can also run the code, or a platform where the question is somewhere, let's say on the right, it's already printed, it's from a pre-selected database. On the right, on the left and on the right, you can type your code and you can experiment with it. Now, we're not using any third platform here. What we'll do is we'll simply simulate that in our Jupyter notebook. Okay, so now we have this notebook running. We've clicked the run button on the Jovian notebook, and here we are. Now the question is, and this is a question that was asked during a coding interview for Amazon. Of course, a lot of other companies may ask similar questions too. Now you are given an array of numbers, and these numbers are all non-negative. You need to find a continuous subarray of the list which adds up to a given sum. This is how an interviewer might state the problem to you. And then they may also tell you an example. Sometimes they don't. And if they don't, it's always a good idea to ask for example. Now, you might sometimes feel that maybe if you ask too many questions, the interviewer might think that you don't know this or you're dumb in some way, but that's not true. It's actually the opposite. The more questions you ask, the better the interviewer is able to convey what they want. Right now, they're busy, they're doing 5 interviews a day and they have their entire day's work. Sometimes they may just fail to state the question in its entirety. And if you don't ask for clarifications, you may assume the wrong thing and go ahead and implement something that's completely wrong. And that completely derails your interview. And trust me, it happens more often than you might think. Okay, so here is one example. So let's say if the interviewer did not provide an example, you can ask them, can you please give me an example for this problem? And then they come back to you and they say, suppose we have this array 1, 7, 4, 2, 1, 3, 11, and 5. These are all numbers and they are all non-negative. Some of these could be 0 as well. But suppose we have this array and I give you the number 10, that I want you to find I want you to find a continuous subarray of the list which adds up to the given sum, which is 10. So then they might also tell you that in this case, the solution is this subarray starting from position 4, starting from the number 4 and going all the way up to 3. And you can check that there are no other ways to create 10. Like if we took 1, 7, that would be 8, and 1, 7, 4 would be 12. On the other hand, 7, 4, 2 would be 12 again, but 4, 2, 1, 3 turns out to be 10. And once again, on the right, you will not be able to create the total of 10. So this subarray is what you have to return. Now, what does it mean to return a subarray? To return a subarray means to return the indices, which is the index of the starting term and the index of the ending term. And sometimes we know in Python, when we're working with ranges, typically the end index is outside of the actual data. So you could return the index of 4 and the index of 11. So that so the index of 4 is 0, 1, 2. So 2 is the index of 4, 3, 4, 5, 6. The index of 11 is 6. So if you return 2 and 6, and then I try to access the 2 to 6, 2:6 range of the list, then you will get this list 4213. And in fact, that's something that we can very quickly verify here. Let's say L1. So you have 1, 7, 4, 2, 1, 3. Now, if I say that the start index I and the end index j are 2 and 6 respectively, and you can see L1 of 2 to 6 is 4213, right? So although j is outside, so that doesn't get included when we put it as a range, and then we put in 4213, and you can also verify that the sum is 10. Okay. All right, so that's the problem. Now I've explained it to you in a lot more detail than an interviewer would, but this is the process that you have to apply in your own mind. And sometimes what you can also do is you can repeat the problem back to the interviewer. That's a great idea. They've stated the problem to you. They've maybe given you an example. Now you state the problem yourself in simple words. Remember, that was step 1. So in the same way that I just have, you can state the problem, and then you have to figure out what are the inputs and the outputs. So the input, you have an array, or array is also a list in Python. So let's say ARR 0. Let's make this an example first input, and that would be 1, 7, 4, 2, 1, 3. And then the target, so your target sum is 10. So that's the input here. And then the output that we want is, so this is the output 0. That would be 2,6 as we've just verified. So this is the input and output format. Always makes sense to just create some variables for that before you start coding. The next step is to think of what are all the cases that a function should be able to handle. But actually, before we do that, we should also write a function signature, because we know what the input looks like. We know what the output is going to look like, and we know what the function should look like. So we can just say def, and let's call this subarray sum. And it's going to take an array, it's going to take a target, and there's going to be some logic inside it. Okay. All right. So that was step 1. Sorry, I forgot about the function signature, but it always helps to just write the function signature, because if you've misunderstood the problem still, the interviewer can immediately correct you and tell you, hey, but you haven't taken a certain input, or you've assumed an input which I have not provided. Okay. All right. So now we have the function signature. Now step 2, remember step 2 was come up with an exhaustive list of test cases to test the problem. So you can do this in comments. You can just create some comments and you can say, I'm thinking about the problem and I'm just trying to think what are all the cases we need to handle. And this is a great quality. This is not something people do often, but they should, because this indicates that you are doing what is called test driven development, which means you are thinking about all the ways in which your code might be used and accounting for those before writing the code. So kind of working backwards, and it's a very useful way to avoid errors. So now the first one could be a generic array where the subarray is in the center, somewhere in the center, right? So which is what we have already seen here. Now the subarray could be in the center, or the subarray could be at the start, or the subarray could be at the end, or it's possible that the subarray, there is no such subarray. So there's no subarray which adds up to 10. You may also have the situation where you have a few zeros. So you have a few zeros in the list. That's one option. Here's one thing that can happen. This could be that there are multiple subarrays with the same sum. Now this is where you might want to just clarify with the interviewer, hey, what happens if we get two subarrays which add up to the same number, the target? And the interviewer might say, find the shortest one, or find the first one, or find any one. But it's always good to clarify that. Next, one option could be that, or you could also ask them what happens if there is no subarray that adds up to 10, and then they may tell you you can return none, or you can return -1, or whatever it is, or assume that there is always a subarray. So that will help you write your code. And then you may have to work with the empty array. You may also have to work with the subarray is a single element. And whenever we say array, we also mean list. In Python, they're practically speaking the same thing for our purposes. Okay, we've listed quite a few test cases, and in that process, we've come across a few more questions which we've clarified. So now we're ready to start solving the problem. Now, at this point, what you may want to do is maybe just ask for a couple of minutes and keep a pen and paper close to you. So I'm going to use this tool instead. Yeah, so I'm going to use this tool instead. So keep a pen and paper close to you so that you can work on this problem. Now let's come up with the simplest possible solution, right? So we have about 2-3 minutes to come up with a solution. And often the simplest solution is pretty obvious. So in this case, one simple solution could be, if I could simply try every subarray, then I will find at least one if that adds up to 10, if there is one. So all I need to do now, each subarray is defined by a start index, that is where the first element of the array is, and then an end index. The end index is just next, the next index, the first index which is not in the array, right? So that's how we defined a subarray, remember? So all we need to do is try all such values. So all such values I comma j, where I goes from 0 to n minus 1, and where j goes from, remember you could start out with the empty subarray, so which means j also has the value I. So here we are saying I and j both have the value 2. So L1 of 2 to 2 becomes the empty array. So j grows from I to all the way beyond the last element, which means if the last element's index is n minus 1, so j can go all the way up to n. All right. So I goes from 0 to n minus 1 and j goes from I to n. And each time we start at an I, and we check each j. So we check j equals 0 and j equals 1, j equals 2, j equals 3, 4, 5, and so on. Then we move I again, and then we start over again, and then we say we start with j equal to 0, j equal to 1, j equal to 2, 3, 4. Okay. And we keep doing this till we find an array, and we've exhausted. This way we'll test all the subarrays so the problem is solved. So that's the brute force solution. And what you should do first of all is explain that brute force solution. It may seem that this is an obvious solution. What's the point of explaining it? But do mention it, because at this point the interviewer knows nothing about you. So they don't know if you can even come up with a solution to the problem, right? They're trying to assess, can you think about problems? And they're trying to assess, can you write code? Now, if you don't tell them the brute force solution, then they don't even know if you figured out the brute force solution. So do tell them the brute force solution. And generally you do not have to code it. You can do the analysis in your memory, in your mind, and you can sort of write the code in your mind, picture the code, and based on that come up with the complexity analysis and directly say that the brute force algorithm will have such and such complexity. Okay. Now we will just write the code right now, just to be very clear about it, in case you are not yet clear on how to write the code. But in an interview, this is the part which you can skip in the interest of time. So def subarray, I think it was called subarray sum. Subarray sum, and let's call this subarray sum 1, the first approach that we're taking. Here we have array 1, and that's it. We have array, and then we have our target. And we're saying, remember that start I from, so I goes from 0 to n minus 1. That was the first thing. So for I in range 0 to n minus 1. And what's n? Well, n is simply the length of the array. Then j goes from I to n. Oops. So I made a small error here. This should say 0 to n, because even in a range, the last value is not taken. So j goes from 0 to I to n. So for j in the range I to, this should be n plus 1 then, because we want j to go all the way up to n. Okay. And now we simply check if the sum of array I to j, right? And we've seen this array I to j is going to give us all the indices starting at I but ending just before j. So if the sum of array I to j equals target, then we found the answer, return I comma j. That's it. So check if subarray sum equals target, and if not, let's just return none none. Maybe this is what we agreed, but let's return none none. And that's it. So that's your code. It's about 1, 2, 3, 4, 5 lines of code, maybe 6. But that's a brute force solution. If it's really short, it doesn't hurt to write it, because then it's going to sit there, and at least as a reference you have it. But it's something you can discuss with the interviewer. I mean, if you are clear about the brute force solution and you can tell its complexity, then you don't have to write. One other tip is, whenever you're coding, it's always helpful to simply add a small comment above, so that even if the interviewer is not able to follow your code, they can just follow your comments and they can tell if your general strategy is correct, right? Once again, reading code is hard, and especially when you are not familiar with the coding best practices in the industry, the code that you write is sometimes difficult to read. So while you learn how to write good code, in the meantime, it always helps to just mention comments. Makes their job easier, makes it easier for them to evaluate you. Otherwise, you may spend 5 to 10 minutes talking about something in your code which either they misunderstood or you made a typo, etc. Okay. So we have here the subarray sum1. We've implemented the brute force solution. Maybe let's also check out some cases and see if this brute force solution works correctly. So in an interview, if you have the ability to run the code, you can just run a few samples. So let's say I simply take array 0 and target 0, and you get the value 26. And remember, output 0 also has the value 26. So great, it seems like our technique worked. Let's test a few more cases just to be sure. Subarray at the end, subarray at the start. Let's see if we can fix that. So here is array 0. Now if I take this, remember 4 to 1, 3. Oops, I think I didn't complete it. Let me also put in 11,5 here. Yeah, so remember 4 to 1, 3 is the solution. Now if we simply take 4 to 1, 3, 11, 5 and call sub array sum and put in this number here and put in, once again, the target 0 was 10. Oh, this should be subarray sum 1. Okay. Yeah, so now you can see 4 to 1, 3 is 0, 1, 2, 3, which is the range 0 to 4. So it seems to have worked correctly. Let's do the same thing. Now this time let's put this at the end. So 1, 7, 4 to 1, 3, 11, 5. This works fine too. 2, 6. Let's try another one. Let's try maybe 17, and that probably cannot be found. Oh, it can. 1, 2. Let's see. 1, 0, 1, 2, 3, 4, 5. Probably the sum of all of these 4 plus 2, 6 plus 4, 10. Okay. Now maybe there's a problem here because it seems like 17 is not the right sum. So you have 1 plus 7, 8. And 8 plus 4, 12. 12 plus 2, 14. 14 plus 4, 18. Okay, so this seems like a mistake then. And we can even check this out. So we have L1. That's that. Let's call that L2. L2. Oh, it says 1 to 6. I think I misread it. So we are ignoring the 0th element. So this does add up to 17. Okay, so 17 does show up. Let's try 18, which takes up the entire array. Works fine. Let's try maybe 4, which should just take the single number. So that works fine too. Let's try 19. That should be none, none. Okay. So we've tested this extensively, and overall our solution seems correct. This is the process. Whenever you write any code, you should also test it out, and it also gives more confidence to the interviewer. But if you do not have the option to test it out, if you're not able to run the code right now, then simply walk them through an example yourself. Like look at this example and then walk them through the example. Okay, so now we have the brute force solution. The next step is to analyze the brute force solution. Now let's analyze it. So you have here one for loop, and we know that counting for loops helps us count the number of operations. Then we have another for loop. So one for loop can go from 0 to n. So this may run n times. Then we have another for loop which goes from I to n plus 1. Let's approximate here and say that it can run at most n minus 1 times or n times. So n, and inside each of these up at most n. And then inside the second for loop, you have the sum. So this is very important. Now always carefully observe the operation inside your for loop. So you have a sum which can be on an array of I to j. Now remember, I can be 0 and j can have the value n. That means in the largest array that you can work with will have approximately the size n as well, right? So you have n, and inside each of those you do n other loops, and inside each loop you do work you do n additions, right? At most n additions. So that roughly gives you that this is going to be n times n times n. So this is going to be an order n cube solution. Okay. So if you are able to arrive at the order n cube solution, the order n cube complexity without implementing the solution, great, you have learned it. But if you're not able to arrive at the order n cube complexity for the brute force solution, then you probably need a little more practice, because this should become second nature to you. Just looking at a problem, identifying the simplest solution, and then finding the complexity of the simplest solution. Okay. All right, so now we have implemented it, tested it, and we've identified the complexity. Remember the next step: find the inefficiency and overcome that inefficiency by applying the right technique. So let's find the inefficiency then. Here we have, let's say we are at this position. So let's say you are looking at 742. Let's say I has the value 1. So you start out with I equal to 1 and j equal to 1 in the inner loop. Then what we do is we increment j by 1, and then we calculate this sum, and this sum is 7. Then what we do is we increment j by 1 more, and we calculate this loop, and this sum is 7 plus 4, 11. Then we increment this window once again, and then we calculate this sum, and that is 7 plus 4 plus 2. So 7 plus 4, 11 plus 2, 13. And then we move this, and then we check it again. So we are doing this over and over and over many times, right? Each time we are doing 7 plus 4 plus 2 plus 1 and 7 plus 4 plus 2 plus 1 plus 3. That seems like a lot of additional work. Maybe we can just avoid that. What we can do is when we start out with a j, we can keep a running sum, and each time simply before incrementing j, add this upcoming element, which is the jth element, into that running sum, right? And that way we don't have to do that entire sum inside each of the inner loops. So that's one optimization, and this is how you should explain it. That's one optimization that I have come up with. The second optimization that we can come up with is that the moment the running sum that we're calculating, the moment the sum becomes greater than the target value, we can skip all of these, right? So we know that 7 plus 4 is greater than 10, and we know that the array only contains non-negative number. So what that means is 7 plus 4 plus any of these numbers is always going to be greater than 10, right? You can see this, the number is not going to decrease if we keep adding positive numbers. And so as soon as the running sum crosses this value, we can break out of the inner loop. We do not need to continue and look for higher values of j. So two optimizations. Helps to just write them down, maintain a running sum so that you don't forget it, and second optimization is when sum exceeds target, break inner loop. Okay, so now we have applied an optimization simply by just looking at the data. In a lot of cases, it's very straightforward. You don't even have to apply any special technique. And in this case, we found these couple of optimizations. So let's apply them. So what we'll do is we'll define def subarray sum2. And here, once again, we have the array and we have the target. And this time we get the length of the array. And now once again, I goes from the same value. So I goes from 0 to n minus 1. Nothing changes here. So for I in range 0 to n minus 1. Now here is where we want to start a running sum. So s equals 0. This is our running sum. Then for j in range, remember we'll start out with I and we'll go all the way. Well, I keep making these mistakes all the time. And by the way, these are called off by 1 errors. Here what we did was I wanted to go till at the address n minus 1, but because ranges do not include the final value, I put in what I put in. N minus 1 was wrong. I should be putting in n. And I make these mistakes all the time, even after many years of coding. So always watch out for off by 1 errors. Anyway, so j can take the range of 0 of I to n. So here we should put in n plus 1. And now, first we want to check if the running sum is equal to the target, right? So assume that we've been calculating the running sum step by step, and we'll write and at this current point the sum has become equal to target. If the sum has become equal to target, then we simply return I comma j, because this sum includes the sum from index I all the way up to just before j. So initially the j also has the value I, so the sum is 0, which makes sense. But if that is not the case, we check if it is greater than the target. So is it possible that our sum has already exceeded the target? In that case, we don't need to continue this inner loop. We can break out of this inner loop, and the way to do that is by simply typing break. And then if neither of these held true, if neither of these was true, so which is that the sum was not equal to the target and it was not greater, that means it is still less than the target. So that means we need to then add array of j into the sum. So we can say sum plus equal to, sum plus equals array of j, which is the same as sum equal to sum plus array of j. In any case, array of sum plus equal to array of j. So we have added the jth element. Now remember, if this is the pointer j, we added the jth element, and then we will set j to j plus 1. That will happen automatically when we come into the next iteration. And the next iteration will once again check if the sum is equal to the target. If it is equal, we return I comma j. Otherwise, we check if it is greater than the target. If it is so, we break. If it is still less, we increment, we move j once again. So we add 1 and then we move j once again, and then we check again, right? So that's our running sum. Looks good. Now, once again, if it was found, it would have been returned somewhere here. Since it seems like it was probably not found, so if we come to the very end, so here we return none. Okay. And once again, let's test it out. So let's try subarray sum 2. It gives you 2, 6. Subarray sum 2 of none. Okay. Seems like there is an issue here. Yes. So this is why you need test cases. So it seems that array j took up an invalid value. So why is that? Well, that was because j can go to the point of n. So the maximum value j can take is n. So which means that you have already arrived at this position. So now you can no longer increase the sum further, right? So if you've arrived at this position, but you've still not reached the total of 10, then that means you may need to increase it further, but you can't increase further. So there's no number here to add. So what we should do is we should here add a check if j less than n. Since j can go all the way up to n. And that's it. So we had a small bug and we fixed it. Now, again, this is something that you should work out for yourself on pen and paper. So even while doing the optimization, you can ask for a couple of minutes, play around with it on pen and paper, write a few examples, relax. You can even take up to 4-5 minutes. And if you're not getting any ideas, you can simply talk to the interviewer. You can speak out loud, explain your thought process, and in a lot of cases they will give you a hint because they want to see you succeeding. Okay. So now this is the second implementation. Let's see. Okay, this time it worked. None. 4213. Let's put in 10 here. This should give you the value 2,6. Let's put in this, so that's 0,3. Let's test this out too, so that's 0,4. Yeah, 0,4. So it seems like it's working just fine. Yeah, so seems like this is working pretty well. So now we have the second optimized solution. So let's look at the optimized solution and analyze it. So we have one loop and then we have a second loop. These two are the same, but inside the second loop, we are simply doing a constant operation. We are just doing some comparisons and one addition, not up to n additions. So the complexity goes from order of n cube to order of n square by maintaining a running sum. Great. Now, at this point, when you have described the solution to the interviewer and maybe also coded it, you might ask them, is this good enough? And they can see that you've thought about it, you've found the solution, and you've tested it, and it tests well. And at this point, they may just say, yeah, I'm happy with the solution, this is good enough. Or they may say, can you do better? Now, when they say, can you do better, most of the time it suggests that there is a better solution. So let's think about it a little more, and let's see if there is a better solution. Now, to can you do better, we apply the exact same technique. We have analyzed the complexity, and now we need to look for inefficiency. Okay. So now we have removed the inefficiency on this side, which is as we move j, that is when we reuse the previous sum to compute the next sum. So we've removed the inefficiency on this side, and we've also added this condition so that j only goes up to a certain point. Now, of course, in the worst case, j may always go up all the way to the end, but at least in a lot of cases, j will not go beyond a point where the sum becomes larger than the target. So these are good optimizations. But what about I? What about the left window? Now look at this here. Now when you have 7, 4, or let's start out all the way at 1. So we have 1. So first we start out with the empty subarray that has the sum 0. Then we increment j, so now the sum becomes 1. Then we increment j, now the sum becomes 8. Then we increment j once again, and now the sum becomes 12. Okay, the sum has become 12. Now that's a problem. So what do? What we are saying is we will take I and set it to the next value, and then we'll bring j back to 0 or back to the value I, so that we start with the empty subarray once again. So now when we do 7, and that just has the value 7, and when we do this, we have to add up 7 plus 4. Now here's something that we could have done instead. Now as soon as the value became larger than the target value, we could have simply moved this here. Does that make sense? Let's think about it. So till this point, this total was less than 10. As soon as we added this number on the right, this total became more than 10. Now we know that this total became more than 10. That means that if we slide this window, if we slide the left window forward one step, then the total may become less than 10, right? It may still stay larger. In this case, it stays larger, or it may become less than 10. So if the total now becomes less than 10, then we can once again move this. But the total has not become less than 10, so we will move this instead. So now the total again is less than 10, so we can once again move this. And now the total is still less than 10, so we move this. Now the total is still less than 10, we move this, and we encounter 10 here. But suppose we had not encountered 10, suppose this number was 4 instead, then what we would have to do is move this, right? And now the number becomes less than 10. So we always try to maintain a window of size less than 10. The moment the window becomes greater than 10, we keep trying to reduce its size further to less than 10, right? Or exactly 10 as well. It's possible that the size may become exactly 10 and then the problem is solved. But we keep trying to reduce its size to a value till it becomes less than 10. So to revise the algorithm, we start out with both I and j at 0. Then we increment j while now we have a single running loop and a single loop essentially. So we increment j while the sum is less than 10. The moment it becomes greater than 10, we start incrementing I. The moment the sum becomes less than 10 or less than target, we start incrementing j. And if we encounter the point where the sum equals 10, we have found the answer. So that's the algorithm. So let's write it. Subarray sum 3. Now this is the array target. Now we have I, we have j, and we have sum. All of them, let's call it s, because sum is a reserved word in Python, an existing function. So all of these have the value 0. Then we say while I is less than len array, let's call that n. So let's create n equal to len arr. I is less than n and j is less than n plus 1. Remember, because j can take the value n as well. It is the exclusive end index. Now at this point you want to check first. So if the sum s, the current sum, running sum, is equal to the target, then we simply return I comma j. If sum is less than the target, then we simply increment j. Okay, so now we can move the window forward. So we are incrementing j if the sum is less than the target. So we increment j, but before we increment j, we should add the jth element to maintain the running sum. So here we say s plus equals j, or array of j. And remember, j can take the value n as well. So that's where we do this only if j is less than n, if there is indeed an element for us to add. This is an error we faced last time, and you will discover this when you write the test anyway. And then we say elif s is greater than target, and we can also just say else here, but just for clarity, let's say elif. In this case, what we want to do is we want to move I forward. So suppose we end up in a situation like this, then we want to move this forward. For that, we need to subtract s array of I first. So we say s minus equals, which is equal to s minus, which is the same as s equals s minus array of I, and then we increment I. So we move the left window forward as well. So we then repeat this. So we first move j to a point, then we, as soon as we cross the target, we start increasing I, and then we keep doing that till we match the target. And then finally we return none comma none if we have not found it. So that's our subarray sum 3. This seems like the most optimized solution, and let's test it out. So here we have subarray sum 3. And let's test subarray sum 3 here as well. Seems like it worked. Let's see. So if you put in 10 here, you get 2 comma 6. Let's say this is 4213, 0 comma 4. Let's put in 12 here. That doesn't show up. Let's put in 17 here, 0 comma 5. 13, 1 comma 5. Let's try 19. That's 3 comma 6. Let's see, 1 plus 3 plus 7 plus 9. Yeah, that has the value 19. Let's throw in a 0 there and see if it works with zeros. That's 3 comma 7. Works fine. And let's see if it doesn't work out. Yeah. Okay. Great. So this solution is correct too. Again, if you don't have the option to run the code, you can simply pick one example and walk through the working of the example. Now we have subarray sum 3. And once again, we are ready to analyze the complexity. And in this case, the complexity would be, this is somewhat tricky. This is a little bit unusual because there is a while loop with 2 variables. But remember that in each while loop, either we exit, which is the best case, so we can ignore that, or we either increment j or we increment I, right? So we increment j or we increment I. And if we increment, so j can go from the values 0 to n, and I can go from the values 0 to n minus 1. So the total number of increments we can do is the sum of the number of possible values of I and number of possible values of j, right? Remember, this is not a product this time because you do not have a nested loop. So for each value of I, you're not doing this. Rather, you are incrementing each one and I only one of them each time. So the sum of total number of values I can take is n. The total number of values j can take is n plus 1. So the total becomes, the number of iterations becomes 2n plus 1. Now, of course, there's you can verify that a constant amount of work is being done here. So we finally end up with the conclusion that this is an order n algorithm. Okay, so this is finally an order n algorithm. So this is a good example of a problem where the step-by-step solution, coming up with a simple solution and then thinking about the inefficiency in the problem and then applying, in this case, just common sense to solve the inefficiency step by step, leads to the perfect solution, and a very good solution in fact. So you start out with an order n cube solution. The order n cube is going to be pretty slow when you start hitting, let's say, even 1,000 elements. If you have 10,000 elements, it will take forever. It will take maybe an hour or so. If you have 1,000,000 elements, it will take hundreds of years. On the other hand, order n can work fine all the way up to 1,000,000,000 elements, right? So there's a huge difference between the subarray sum 1, 2, and 3. Subarray sum 3 can work instantly for 1,000,000,000 elements. Subarray sum 1 will take forever, even for 100,000 elements. And subarray 2 is in between, and you can do the math. And this technique, where you can almost certainly tell what the next step is. So this was not really related to any of the algorithms or data structures that we have talked about. This is what is called a greedy approach, where you know some optimal strategy about the problem. In this case, you know that we can calculate the sums by maintaining a running sum. So we just do that. And then you also know that as soon as it becomes greater than a target, we need to break out. And then you know the next thing, that when it becomes greater than the target, rather, you can simply update I. So this is what is called a greedy approach, where you somehow know that just doing this will fix it, right? There's no real technique to be applied. And these problems are somewhat tricky, but you get the hang of these problems as well. If you search for greedy problems online, you get the hang of these by solving a few practice exercises. Okay. So that's our first interview problem. And we've solved it in about 45 minutes. And this is approximately how long you will have for an interview. A typical 45-minute to 1 hour interview will have about a couple of minutes of introduction, maybe a few minutes just you talking about a project and the interviewer asking you questions. But then the next 30 to 40 minutes will be dedicated towards solving a problem. And this is what roughly the process will look like. Let's do one more example. Let's pick another interview question and let's see if we can solve this one. So this is slightly different. So this gives us one more variation to study. By the way, to run these, you simply click the run button and select run on binder. Okay, so this is an interview question that was asked during a coding interview at Google. And the question is given two strings A and B. Find the minimum number of steps required to convert A into B. So what you can do is you can perform operations, and each operation is counted as one step. And the operations you can perform on a word are these. You can either insert a character into the word, or you can delete a character from the word. So for instance, here you can see that we are trying to convert intention into execution. So either you can insert a character, for example, you could insert C here, or you can delete a character. For example, you can delete I here, or you can replace a character. That is, you can take N and replace it with E. You can take T and replace it with X, and E does not need to be replaced. And here we've inserted C, and then here we've substituted N for U, right? So we've taken the word intention, and by performing a few changes character by character, by either inserting, deleting, or replacing a character, we have converted it into the string execution. So the number of steps required here is 1, 2, 3, 4, 5. Now here's a challenge for you. Try and work this out on paper and prove that this is the best solution. So because we need to find the minimum number of steps required to convert A to B. Okay. So that's the problem. And this is a moderately hard problem, and variations of this show up as well. So let's start applying the method. Now, when you hear the problem, a solution may not strike you up front. That's perfectly all right. Don't panic. Sometimes when you're not able to immediately come up with a solution or identify how to solve this problem, you enter a sort of panic and then you're unable to think. Don't do that. Remember, have faith in the method, and we will apply the method and come up with a solution step by step. So the first thing is to state the problem in your own words. So given two strings, we need to perform operations, a series of operations on the first string. So the operations could be deletion of a character, substitution of a character with another character, or insertion of a character. And through these operations, we need to convert it into a second string. Okay, we have understood the problem. If the interviewer had not given an example, either you can state the example or you can just ask for an example, whatever works for you. So we've stated the problem. Now, what are the inputs to the problem? So the inputs are two strings. So the inputs are strings like intention and execution. So let's see, maybe let's call them str1. This is intention. str2. This is execution. Now, one thing you have to be careful about here is you do not want to capitalize, because sometimes what might happen is this I may match up with an I here in the proper solution, but Python obviously treats small and capital letters differently. Python doesn't know that the I which is lowercase and the I which is uppercase is the same. So you will not be able to compare them. So just to keep things simple, either make everything uppercase or make everything lowercase. But yeah, this is what the input looks like. And the output is going to be a single number. So the output is simply going to be the edit distance. So let's just call it output 1, and it is going to be the number 5. And here is something that you can verify. So that's the input, that's the output. And function signature. So of course this term edit distance is how this problem is described, but here there is no there's no concept of edit distance that's mentioned. So you can give a function name that makes sense for this problem. So find the minimum number of steps required to convert A to B. Okay, so let's just call it min steps for now. So the function definition would be min steps, and this would take an str1 and this would take an str2, and it would return an output. For now, we'll just put in pass here. All right, so now we have already clarified the problem. If you had any questions, this would have been a good time to ask the interviewer and make sure that you have a clear understanding. Now you have stated the input, output, and function signature. The problem has been communicated back and forth properly. The first step is done. The next step is to list out some test cases, right? Once again, a very good quality listing out some test cases. So you can say that now I'm just going to list out a few cases that I want my function to cover, so that they will help me. It will help me while writing the code. Now, one is the general case, which is listed above. So this would be intention, execution, and we can take a few more examples like this. Now, one example could be where no change is required. So you are given the same strings. One case could be that all the characters need to be changed. So these are the two extreme cases. One is no change is required, and second is all characters need to be changed, maybe added, removed, deleted, lots of such things. Then you can check both strings of equal length. So in this case, they are in fact of equal length. Unequal length, you can check both strings of unequal length. One of the strings is empty. Your function should be able to handle that too. Then you may check things like if something only requires deletion, if something only requires addition, or if something only requires swapping, right? Such things. I guess this is pretty good at this point. So now we can probably move forward. So we have stated some test cases. Now you don't need to create all the test cases right now in an interview. It can take a bit of time. So let's just move ahead, and the next step is to come up with the simplest solution to the problem, which is also called the brute force solution. So now we have a lot more information about the problem. And in this meantime, probably it has sunk into you and you may have been able to think of a brute force solution. But if not, don't worry. There is a simple trick I'll tell you which you can apply whenever you are stuck and you can't think of a brute force solution. So you're looking at it, intention, execution. What am I going to do? Am I going to start from the left and right? How do I check which one is, how do I know if this is supposed to be inserted or executed or replaced or substituted or deleted? So the simple trick is, whenever you're in doubt, think about recursion. See if there is a way to solve this problem recursively. And what do you mean by solving a problem recursively? Can you reduce the overall problem to a combination of one or more sub problems? So if you take a portion of the input, and can you solve the same problem on the portion of the input and then use that to solve the overall problem? Okay. So let's see if there is a recursive solution possible here. So here I have the same thing, intention and execution. Now with recursive solutions, normally you either start by looking at the first character or the last character. So let's look at the first character of each string, right? So we're given these two strings and we need to find the number of operations to change this string into this string. Let's look at the first character. Now suppose the first characters were in fact equal. Suppose this was not intention, but this was intention and this was execution. So now we compare the first characters and we know that the first characters are equal. Okay, so if the first characters are equal, then obviously neither of them needs to be deleted or removed, or obviously this character does not need to be deleted or removed or switched. It's already matching. So what we can do is we can just ignore the first characters and we can simply look at the remaining string. Okay, so intention and execution, because the first characters are already equal. Let's write that down so that we don't forget it. And this is the recursive solution. Now this is where you can take a moment to work this out on pen and paper, and that's perfectly all right. What helps is to just keep talking about what you're doing. But for recursion, now first thing we know is if the first character is equal, then ignore from both. So you just ignore the first character of both strings and simply recursively solve the problem for the sub list or the substring without the first characters in each of the strings, right? So you exclude E and exclude E from this and solve the problem for these two. Perfect. Now suppose the first character isn't equal. So that's another case now, right? So that is the case where you have intention and execution. So if the first character is not equal, then either the first character has to be deleted or the first character has to be swapped. So you may have to swap I with E, or the first character, or maybe something needs to be added before the first character. Okay, now let's see one by one. So if the first character is not equal, either it has to be deleted or swapped, or a character inserted before it. There are only three possibilities, right? Of course, it's possible that we may do some other things, insert characters after it and so on, but at that position, after applying an operation, either the first character will get deleted or the first character will get swapped and will be changed to E, or the first character will now change to something else and the original first character will become the second character. Okay. Now let's look at each case. The first case is if it is deleted. Now the beauty of recursion is that we don't need to guess which solution it is. We can try all three recursively and then simply pick the best one. So suppose we choose to delete the first character. So suppose we say that we are deleting the first character. Now what that means is we've performed one operation and we've deleted the first character. So now what we are left with is this. So now what we end up is the string has remained the same, only the first string has changed where we have lost the first character. Now what we end up with is with a sub problem where we need to find the minimum number of steps to change intention, N-T-E-N-T-I-O-N, into execution. Okay. So in this case, if it has to be deleted, then recursively find, then recursively solve after ignoring first character of str1. Okay, that's one possibility. And you get the recursive solution and you simply add 1 to it. That tells you the solution if you delete the first character. The next option is that we change the first character I to E. Now if we change the first character I to E, so one operation has been performed, and then now these two have become equal. Now that these two have become equal, we can move this forward and we can move this forward. So now we can simply recursively solve the problem for intention and execution, find the minimum edit distance between the two, and simply add 1 to it to get the number of steps required to change intention to execution by swapping the first character, right, from I to E. So in this case, you recursively solve after ignoring the first character of each, right? So it is 1 plus, in both cases it is 1 plus the recursive solution after ignoring the first character of each, because the one operation is something that has been performed. Okay, now the final case. The final case is you have intention and execution. Now we decide that we are going to shift the string forward, and we are going to introduce an E here. So we are going to introduce E here. So now what happens is the E is matching the E. Now I has gone on to the first position. I has gone on to the next position here. So effectively what has happened is that we need to recursively solve the problem for the original string intention and the second string with the first character removed, because we have inserted something before the first character in the first string. So that is going to match with the first character of the second string. And hence we simply need to recursively solve the problem for these two. So in this case, what we are doing is the solution is 1 plus recursively solve after ignoring the first character of str2. Okay, sounds good. Looks like we've done that. Now what's the end solution going to look like, the end case? Remember, in recursion, this is all well and good, but at some point we are going to hit some kind of an end. So let's see if we can define such an end scenario. So maybe let's say we have been performing recursion and then we ended up at a situation like this where there is nothing left in the second string, but you still have some characters left in the first string, right? So you're at this position now, and here this is gone. There's nothing left in the second string. So in this case, to change to change TION into the empty string, all we need to do is delete all 4. So if you have a few characters, if the second string becomes empty, then you simply find the number of remaining characters in the first string and delete them. So that is the number of operations, 4. The other possibility is that the second string still has some characters, but you've run out of characters on the first string. So if you've run out of characters on the first string, but the second string still has some characters, then in that case, what you need to do obviously is you have the empty string and you need to take this, convert this empty string into TION. That is a recursive problem we are solving. So you can do by adding TION. Great. So you add TION, and that is again going to be 4 steps, which is the number of characters remaining in the second string. Okay. So these are the 2 end cases. Now, of course, if both of them are empty, then the answer is 0. But if either of them is empty, the answer is the number of remaining elements in the other one. So let's write the solution. Now we figured out the solution. It took some time, but again, this is not a very straightforward problem. So there are a few cases to figure out. And while you are doing this, while you're identifying each case, either you can say it out loud to the instructor or you can write it as a comment, whatever you feel more convenient with, because the interviewer cannot see the work that you're doing on paper. So it's very important for you to be able to convey it. And that is why all this while in this course, we have been saying that you need to express the solution in simple words, because you need to tell the other person that you know the solution and they should be able to understand what you're saying without looking at your work, without looking at the images that you've drawn. And a great way to do it is either by writing or by speaking. Let's define it then. Def, what's it called? Min steps. And min steps is, it takes str1 and str2. Great. Now we are doing recursion, and in recursion what we're tracking is the which character we are currently at. So we could be at the 0th character or the first character or the second character in string 1, and we could be at the 0th character, first character, second character in string 2, right? So the starting point of this window determines the sub string that we are solving the problem for. So ideally, when we want to solve this problem for these two substrings, we can simply pass those substrings, but creating sub lists or substrings has a cost, because you have to copy those characters out and then allocate some memory and put them into a new place. So an easier way is to simply keep a pointer. So we will keep 2 pointers, I1 and I2, and these will signify that we should be skipping, while computing min steps, we should be skipping the first I1 characters, or we should be starting from the I1th index and we should be starting from the I2th index for str2. Okay. So in your window, if the I1th index, if the starting index is equal to the length of string 1, so this is the end case, and remember the end case while coding is always written first. So if this is equal to length of str1, then we have seen here that we need to perform these many additions. So we simply return, in this case, len of str2 minus I2, right? And you can verify that this is the number of additions required. Elif, on the other hand, I2 is equal to len of str2, so which means that you have exhausted the second string, but the first string still has some values left. So in this case, you need to delete the remaining values in the first string. So you just type len of str1 minus I1. Great. So these we have now solved the trivial cases. Now let's see elif str1 of I1 and str2 of I2, which means the first characters of each substring that we are working with, right? Remember, we are just using arrays as we're just using indices as a optimization. What we really want to work with is substring. So the first character of each substring, str1 of I1 and str2 of I2, is equal. Now if the first character is equal, E and I are equal, then we simply ignore both and solve the problem for the remaining string. So we simply say return min steps, and we pass in str1, we pass in str2, and then we simply pass in I1 plus 1 here, and we pass in I2 plus 1 here. So what this is saying is that now we want to recursively solve the problem for a substring starting at I1 plus 1. So we have ignored the first string of the current substring, and similarly we have ignored the first character of the current substring of the second string. Okay, so we ignore the first characters and that's it, and there are no steps required here, no operations required here right now, because the first characters are equal. Now finally, this is the final case, else. Here we want to return 1, so we have to perform one operation, either it is an insertion, deletion or swap, and what we can do is we can recursively check the cost or the number of minimum steps required for each case of insertion, deletion and swapping, and simply pick the minimum one, and if to it we add 1, then we get the total minimum number of steps we need to perform for the entire list, right? So again, recursion is very useful because you can simply assume that you have the function which solves the problem, and you simply need to take the result of the subproblem and combine them. So we take the minimum of, the first option is if the first character of str1 has to be deleted. So which is, let's say we choose to delete I. If we choose to delete I, then that means we have to solve the problem for these two. So we say 1 plus recursively solve the problem after ignoring the first character of str1. So we solve min steps for str1, str2. Now since we've deleted the first character of str1, we can skip ahead into the next, because we are solving the problem now for starting from the next index, and I2 remains the same, right? So remember, here we have not affected I2. So we need to solve this problem recursively. So this was the case of deletion. Next, we have the option where you have swapped the first character. So we have taken E and we have converted we have taken I, converted it into an E. If we did that, so then we can say that, okay, now these two characters are matching. So now we can simply recursively solve the problem for the next character onwards after ignoring the current character. So this becomes str1 plus str2 plus I1 plus 1 plus I2 plus 1. Great. So this is swap or replace. And you might notice that this turns out to be the same recursive call as this, except that we will add 1 to it because we have done the swap. And finally, if you are adding, so if you're inserting, so finally, if you're inserting here something, so if you are inserting E here, let's say, so in this case, what we'll do is now we'll recursively solve the problem for intention and execution without the E in front. So we skip the first character of the second string. So we have min steps str1, str2, I1 and I2 plus 1. So this is rather nice and symmetric. And that's it. So this should be it. Let's run this. Okay, there is a syntax error here. That's perfectly fine. There needs to be a comma here. That's fine too. I make a lot of syntax errors all the time. And of course, off by 1 errors. I'm sure there are a few. But yeah, this is the minimum number of steps. And this is the recursive function. Not too bad. 2, 4, 6, around 8 lines of code. And let's test out some of the test cases here. I'm just going to copy the test cases out here below. And let's test the general case, which is intention and exception. So let's see min steps, intention and exception. It says 4. Okay, why does it say 4? Maybe let's test a more simpler case first, which is one of the strings being empty. Let's say we have intention and one of the strings is empty. So we will need to delete, let's just say int, and one of the strings is empty. This looks fine. We will need to delete all 3 of these. And that in some way tests out this case where, tests out the second case where the second string is empty. Now we can test this case. In this case also the solution is 3. Great, looks fine. Let's test this case where str1 I1 and str2 I2 are equal. So if you have integer and let's say you have India, so in would be the same. So these would get skipped. And here is where the recursion would kick in. So T would have to be changed to D, and then you would have to add I and A. Okay, that looks fine too. And let's check intention and exception once again. I don't know what's wrong here. Let's see. So is it possible to do it with 4? I don't know. It's maybe possible to do it with just 4 changes. If you change I, you delete I, and then you delete N, and then you delete T. Delete I, substitute these 2. I don't think it is possible with just 4 changes. So there's probably an issue. I don't know what's wrong here. It's possible I may have made a mistake here. Let me try another. Saturday and Sunday. Okay. So Saturday, SATUR, needs to be changed to Sunday, SUN. Now S is the same, so ATUR needs to be changed to UN. So U remains the same. Now if we can, what we can do is we can probably delete A, delete T, and replace R with N. So this seems to be fine. All right, so we'll probably, unless I'm not seeing this, so you have intention and you have exception. Unless I'm not seeing something, it seems like we may have made a mistake. One thing we could do is we can simply print out the strings that we are checking. So let's see, str1 is I1 onwards and str2 is I2 onwards. So we're first checking intention and exception, then we check, let's also print the result here. Okay, so at this point I would probably look through the loop here and see if it is correct, coming properly. So you have intention and exception. First we delete I, then we delete N, then we delete N, then we delete T, then we delete, okay, then we compare E and E. So then we come back to N and exception and so on. I think this might take some time to fix. We'll come back to intention and exception. But supposing we've solved the supposing we've written the recursive solution correctly, and I do have the recursive solution here. So let me just grab that and put that in here. Let's see what's different. Okay, probably the answer is 4 because I'm still getting 4. But supposing we have the recursive solution here. So we have min, edit, distance. This is the recursive solution. And now what you need to do is you need to find out the complexity of the recursive solution. So now to find the complexity of the recursive solution, what we can do is simply look at the recursive calls in the worst case. So how you start out is you start out with a string of length n1, let's say, and a string of length n2. You have one string of length n1 and one string of length n2. Then you call this min, edit, distance with I1 plus 1 and I2 plus 1. So str1 and str2, you call them with I1 plus 1 and I2 plus 1. So that's one possibility. Or you call 3 recursive calls. Now one recursive call is the good case where these two match up. So we want to look at the worst case where these two things don't match up. So in that case, you make 3 recursive calls, right? So you make 3 recursive calls, and in each recursive call, you are then going to reduce the problem size by 1. So you're either going to decrease I2, or you're either going to decrease the size of the first string, or you're going to decrease the size of the second string, or you're going to decrease the sizes of both strings, right? So just to keep things simple, let's assume that in all 3 we are decreasing the size of either one of the strings by 1. So we are decreasing the total problem size, which is n1 plus n2 by 1, right? So the number of levels of recursion is going to be the total length of each of the 2 strings. So let's maybe just draw that graph here as well. So let's take this. So here you have n1 comma n2. So let's assume these are the lengths of the 2 strings. Now n1 plus n2, what happens to it? Is that this n1 plus n2 calls 3 recursive functions. So there are 3 recursive functions. So let's just draw those 3 recursive functions. So we have those three recursive functions here. Let's take this too. And then in those three recursive functions, what we have is either you reduce the size of the first string, or you reduce the size of the second string, or you reduce the size of both strings. So either you end up with n1 minus 1 and n2, and let's reduce the size of that, or we end up with n1 and n2 minus 1, or we end up with n1 minus 1 and n2 minus 1. Okay, so these are the three recursive calls that we're doing, and then each of these will once again make three more recursive calls. And so on. Now, what is the overall depth of this recursive call? Now, because we can see that each time the size of the problem reduces by 1. So if the size of the problem is n1 plus n2, in this case it reduces by 1, in this case it reduces by 1, and in this case it reduces by 2, but for simplification, let's say it reduces by 1 here. So the total size of the problem, the total number of levels in this tree, is going to be n1 plus n2. So you have three problems in the first layer. The second layer will have three square problems. The third layer will have three cube problems. So 3 times 3 times 3. And similarly, you can go ahead and you will find that at the last layer, you'll have 3 to the power n1 plus n2 minus 1 layers, right? And if you then add together all the layers, what you end up with is that total number of subproblems is 3 to the power n1 plus n2, right? So you have a total of 3 to the power n1 plus n2 subproblems that you end up creating. And because of that, you have the complexity 3 to the power of n1 plus n2 in this case. Okay, so that's the complexity. So here we have a recursive solution, and then we have the complexity of the recursive solution, which is exponential, 3 to the power of n1 plus n2. Now at this point, it will make sense to add memoization. So whenever you see recursive solutions and you see repeated problems, for example, here itself you can see a repeated problem. And then you can see that this problem will get repeated inside this problem and inside this problem too. So there are a lot of repetitions, and all we need to do is remove some of those repetitions. And to remove those repetitions, we can use memoization. So what happens in the memoized solution? It is exactly the same as the recursive solution, but before doing any computation, we check a memo, we check a dictionary if we already have the solution for the changing variables, which is I1 and I2. And if we have those solutions, what we need to do is just return them directly. If we do not have those solutions, we need to compute the solutions, put them in the memo, and then return the value from the memo. So let's write the memoized version. So we have min edit distance with str1 and str2, and this we are calling memo. Okay, this we are calling memo. So now we have a memo. The memo is going to be a dictionary, and the dictionary is empty. And then we define a function recurse. So in memoization, normally you have to write a recursive helper function. Now you can either write this outside or inside. I like writing this inside because, well, it will have access to str2 and they do not need to be passed in. So here we have I1 and I2. And first thing we do is we create a key. So the key is I1, I2. Now if key in memo, which means if we have already computed the solution, then we simply return memo of key. If not, then we have all the other cases. So now we have elif. Now we can check if I1 equals len of str1, In that case, don't return. Set the memo of key to len of str2 minus I2. Elif I2 equals len of str2. Then we return memo of key is len of str1 minus I1. Elif, okay, in this case, then we check if the first elements are equal. So we have the exact same logic. You can see the same cases coming up here. So if you have str1 of I1 equals str2 of I2, in this case, we have memo of key equals, we simply ignore the first character. So we increment I1 and I2. So exactly what we have done here. So we simply call recurse this time with I1 plus 1 and I2 plus 1, right? So we always call the recursive function, but inside the recursive function, if it has already been computed, it will return from the memo. And finally, if we have, and this is the final case, which is where they are not equal. So here memo of key becomes 1 plus min of, let's see here. So we have recurse. So the insertion cases, we will ignore the first element. Sorry, the deletion cases, we will ignore the first element of the current range from the first string. So we call recurse with I1 plus 1 and I2. Otherwise, we call recurse with I1 plus 1 and I2 plus 1. This is the case where we swap the first element of the first string. So we can just recursively check after ignoring the first element of each. And then we have recurse with I1 comma I2 plus 1. I2 plus 1. And there we go. And that's it. So now we have stored it in the memo, and then we simply return memo of key at the very end. And finally, we call recurse 0, 0, and that is our solution. Okay. And there is a syntax error. You can fix these syntax errors. They're easy to fix. And I've just realized that the solution in this case might actually be 4, because what we can do is we can change n to p. So that's one step. We can replace I and t with exc. So we replace I and t with exc. That's 3 changes. We don't change e, and we replace n with p. The solution is 4. So our solution was correct. There was no issue there. In fact, this is not the best solution. This is a suboptimal solution. So this output should be 4. And that's okay. This is something that happens all the time, where you miss something and you just assume that, you just say that you're going to come back to it at the end, and then you move forward assuming that that code was right, and then you realize that either you were correct or what your mistake was. It's probably going to happen in one of 5 interviews anyway. Okay, so now we've written a memoized solution. Great. And we can start checking the memoized solution now. So minimum edit distance memo. So let's call min edit distance memo, and we get back the value 4. Looks fine. Let's try Saturday and Sunday as we have. So that's 3. So what you will do is you will leave a as it is, change ATUR to UN by removing AT and changing R to N. That seems fine. Let's test out some cases like this. Okay, this is 3, 6, 8 characters. So that seems right. We simply delete all the characters. Let's check out this. Here also 8 characters. We have to add 8 characters. Let's say we have ABC and XYZ. So this should be 3. If it is XYZK, then maybe that will be 4. What if it's XYZA? In this case also it's 4. So this seems to be working fine. We have now taken the recursive solution, identified the inefficiency, calculated the complexity, which was exponential, identified the inefficiency, and which was repeated subproblems, and then fixed the inefficiency by calling min edit by using memoization. And now how do you compute the time complexity of memoization? Well, the argument is if you only need to compute the solution for a key once, and the computation apart from the recursive calls simply involves some comparison and a fixed number of comparison and an addition. So the time required to compute, assuming you have the recursive solutions, is constant. So that means if you simply count the number of memoizations that can possibly occur, that gives you an upper bound on the total number of operations. It will be some multiple of that, some constant multiple. So I1 can take the value 0 to n1, where n1 is the length of string 1, and I2 can take the value 0 to n2, where n2 is the length of string 2. So memo, the keys in memo can be I1, I2. So you have n1 values for I1, n2 values for I2. So that makes it n1 times n2. That's the number of keys, and that because there's a constant amount of time, additional time required to compute the solution for a key, that is also the complexity. So the complexity is order n1 plus n2. So we've gone from 3 to the power of n1 plus n2, which grows very quickly. Even for 3 to the power of 10 is pretty high. We can check it out here. 3 to the power of 10 is something like 59,000. 3 to the power of 100. So if you have n1 plus n2, then that's e to the 47. That's going to be a lot of operations. On the other hand, if with memoization, it is only going to take, let's say the 100 is split as two strings of length 50 and 50, only going to take 2,500 operations. So where it was taking 10 to the 47 operations, now it takes only 2,500 operations, which is pretty small. So you can still work with lists of size up to 10,000 or 100,000 very easily using the memoized solution. So that covers this problem. And keep talking through your solution even as you're stuck, even as you're confused, just as I was. It's helpful to just spend maybe 2 or 3 minutes trying to solve the issue. And if you're not able to solve the issue, just say that this is something I'll fix later, and then move on, assuming that you've fixed it, and then keep talking and keep working on the solution. And at some point later, it's possible that the solution might strike you. Okay. Now at this point, you may be asked sometimes to implement a dynamic programming or an iterative solution. Like when you talk to the interviewer and you're telling them that this is how I'm thinking, I'll do a recursive solution first, and I can see that maybe there are going to be some subproblems there. Then I'm going to apply dynamic programming. So you can just check with them, and in most cases they will accept a memoization solution, because the dynamic programming solutions can take a little bit of time to solve, to implement, and there are always off by one errors, and it's also difficult to explain the solution. So you can most cases get away with memoization. But if they do ask you to do it iteratively with dynamic programming, then you'll have to go ahead and implement the dynamic programming solution. So once again, take a couple of minutes now and work it out on a piece of paper, and then go back to them. Now for dynamic programming, remember you have to create a table essentially. So what the table will look like in this case is, let's see if we can simulate a table. So what the table will look like is, let's create a new sheet. And in this sheet, let us put the two words, which is intention okay, and let's put the word exception as well. Move this down too, and let's also put in the indices. Ultimately, this is what a dynamic programming problem looks like. You are ultimately going to create a table here. And how we'll start filling the table is the ijth element. So let's say this element INTE. So this element represents the edit distance or the number of operations required to convert INTE into EXCE. And how do you check what the solution is? Now, you know that E and E are equal. So the final elements are equal. So what that means is we look at this value, then this value should tell us what is the minimum edit distance between EXE and EXC. Now, since we can simply add E to each string and get this solution, that means this solution is equal, this value is equal to this value. All right. So in the case where the corresponding elements are equal, we simply copy over the value diagonally left, top left value onto the current cell. The other option is if they are not equal. So let's say if we are here, where here you have N and here you have P. Now there are three possibilities. You want to find the minimum edit distance between INTEN and EXCEP. Now N is not equal to P and this is the original string. So either we delete N. Now if we delete N, then we need to find the solution for INTE and EXCEP. So if we delete N, then this value will become 1 plus this value. That's one possibility. Or another possibility is that we swap N. So we swap N for P. So now you get this becomes P and this becomes P. So this value will become 1 plus this value, because now we can ignore the P and simply get this previous solution for EXCE and INTE. So this value becomes 1 plus this value. Or the final option is that you can insert something just before N. So if you insert something just before N, which is going to be P. So if you insert P just before N, sorry, you insert P just after N, not before. If you insert P just after N, then you have P after it already. So you can just look at this value, and this value is going to be 1 more than this value in the case that you insert P after N, right? So there are three ways to come to this value, either by deleting N, or by inserting P, or by changing N to P. And what you can do is you can take the minimum of these three values and add 1 to obtain this value. So that's the logic, roughly speaking. And you start from the left. So you see, okay, E and I, they are unequal. So you need one operation to change them, and there's nothing else to consider. So that's done. Then E and N, they are unequal. Now what you can do is you can either delete N. If you delete N, then you simply need to check E and I. And you know that the solution for E and I is 1. So this would be 2. Another option is that you could possibly insert something. But if you insert something, the length of IN is going to increase. So that's going to cause a problem. So you can't insert anything. Another option is you change N with E. But if you change N with E, then you will no longer be able to. If you change N with E, then you will no longer be able to use this solution, right? Because now you will have to match I with the empty list. So that's going to be 1 as well. So overall you end up with 2. And this is how you start filling the list. So you start filling up from left to right and left to right and keep going top to bottom. And as you fill out this list, finally you will fill out this final value, exception and intention, and that will be your solution. So that's the dynamic programming solution, and you can see that it's getting tricky to convey the entire solution because there are so many cases involved here. So typically you will not find dynamic programming solutions requested in interviews, and it will help you to just stick to the memoization solutions. All right. So with that, we have covered 2 common interview questions, and you can keep going. So the idea here is to just apply the method. Remember the method, the problem solving template that we've covered. State the problem, identify input and output formats, write a function signature, come up with some example inputs and outputs, or at least the scenarios, come up with a correct solution, state it in plain English, implement the solution, test it using example inputs, and fix bugs if you face any. Then analyze the algorithm's complexity and identify inefficiencies, and finally apply the right technique to overcome the inefficiency. And you repeat the process, going back and stating the solution, implementing, analyzing, and repeating. Now, in some cases, you do not need to implement the brute force solution if you don't have the time. But when you're working with recursive solutions, it always helps to implement brute force first before you do memoization or dynamic programming. And some tips: ask questions, as many questions as you can, as many as you need to clarify the problem. Show an example, follow the method, don't panic. If you get stuck at a certain point, give it a couple of minutes. Sometimes you can even ask the interviewer and they may be able to tell you that maybe what your error is, or maybe you're not stuck at all, what you're simply assuming something incorrectly. But beyond a few minutes, what you want to say is that I'll fix this later, assuming this is correct, let's move on, and then talk about complexity and optimization and such and such. Okay. Very important is to state the brute force solution to the interviewer, and if you are unable to figure out a more optimal solution, then the best thing you can do is to offer to implement the brute force solution, so that you can at least demonstrate that you are able to write code. And it's all right, in a lot of cases you will not be able to figure out the optimal solution, and in some cases there may not be an optimal way. So there are certain problems where there is just one way, and that is the hard way or the brute force way. And this is typically very true with a family of problems called backtracking, something we've not really covered in a lot of detail, but it is also another form of recursion. So what do you do next? So the next step for you is to review this lecture video and solve these problems yourself, or take more problems. Ideally, what you want to do is you want to take all the 5 different techniques that we've covered, and let's quickly review what those 5 techniques were. The first one was binary search. So we looked at linear search and binary search, which is a form of divide and conquer. And along with that, we also understood the complexity and big O notation. And then you had some homework on linked list and Python classes. But binary search is something that comes up often. And the hint to detect binary search is simply to look for order. Whenever you see something being mentioned as sorted, now that is an indication for you that this may be binary search. Sometimes what you may have to do is you may have to get things into a sorted form, maybe by replacing elements by sum of values till that element or so on. And once you get things into a sorted form, maybe then you can do binary search. That's one way to go about it. And once again, just do 5 to 10 problems on binary search and you will be able to identify pretty much any binary search question in an interview. Then the next topic that we looked at was binary search trees, traversals. And here is something that is generally asked very directly. So you will be given a question like binary search tree, do something with a binary search tree, and you can answer that question directly. We've covered a lot of different things here, so do check out lesson 2 for all the different things you can do with binary search trees, traversals, balancing, and most of these are recursive solutions. So it's also a good exercise on recursion. And we've also looked at balanced binary trees and how can we optimize them further. Then you had an assignment on hash tables. So hashing is again a common question that is often asked. So we built hash tables from scratch in Python, and we also handled collisions using a technique called linear probing. And so this is something you can check out in assignment 2. So you may get asked just to implement a hash table in Python or implement collision resolution in a hash table, in which case you can use linear probing. Then you have the sorting algorithms, where we looked at bubble sort and insertion sort, merge sort using divide and conquer, and quick sort, where we had a quadratic worst case complexity but a logarithmic average complexity. And that's a good thing, because merge sort, although it is logarithmic in the worst case, it still takes up a lot of space, and space allocation is slow, and you may also not have the memory. So that's why we sometimes prefer quick sort over merge sort when we are constrained for space. Then assignment 3 is pretty interesting, where you will implement an optimal algorithm for polynomial multiplication using divide and conquer. So do check out assignment 3 as well. Then we looked at dynamic programming, we looked at recursion, memoization, subsequence and knapsack problems, and then we finally also didn't cover backtracking and pruning, but there are some questions there in the lesson notebook which you can try out, which use backtracking and pruning as well. Then we looked at graph algorithms the last time, which was graphs and adjacency lists and adjacency matrices. We looked at the depth first and breadth first search and how to implement them. And we also looked at shortest paths and directed and weighted graphs. This is a very important topic, breadth first and depth first search. You will get many questions related to these. So do solve maybe 5 questions on each of these topics. And you should be good with most graph problems asked in interviews. Now this project for you, the course project, if you haven't seen it already, is to pick a coding problem. So you can pick a coding problem from an online source like LeetCode, HackerRank, Geeks for Geeks, etc. And then use the problem solving template that we've shared with you. This problem solving template as a starting point. So just give it a name and then write the problem statement and implement the solution step by step. So use the problem solving template to solve the problem using the method you've learned in the course. Then document your solution, add explanations wherever required, perform the complexity analysis. All of this you should add in the Jupyter notebook and then publish your notebook to your Jovian profile. And finally, you can submit the link to your Jovian notebook here. Do submit the link to your Jovian notebook here. And you can check out the discussion where you can change, where you can post what you're working on. So do post your notebook as well. And finally, today we have looked at a couple of real interview questions from Amazon and Google and how to go about solving them. And we also addressed a few issues that we faced along the way. So that was a helpful exercise. And that's it. So now you can review the lecture video, execute the Jupyter notebooks, complete the assignments and attempt the optional questions so that the topics that we've covered, they get consolidated and you do not ever have to look at this lecture again, right? So practice is what really reinforces and consolidates your learning. Complete the assignments and attempt the optional questions to practice and participate in forum discussions. Also very useful when you participate in forum discussions. By answering questions, a lot of your own doubts get cleared. So do participate in forum discussions and then join or start a study group if possible. Getting together with a group of 4 or 5 people is great. It really helps you focus and improve your understanding by discussion. So that's data structures and algorithms in Python. So with that, thank you very much for joining us on this journey as we learn data structures and algorithms in Python. A very useful topic to improve your coding skills and also something that you will almost certainly encounter in one of your interviews, no matter which company you're applying to. So I hope this is helpful to you. Do let us know on the forum how this course helped you. If it did, you can let us know in the YouTube comments as well. If you have questions, if something was not clear, do post that too. And we'll make sure to come up with clearer explanations and clearer examples the next time. If you have any feedback for us, do post it in the comments or send us an email at support@jovian.ai. With that, I will take leave and I will see you in the forums. This is not the end of our journey with you. So do stay active on Jovian. There's a lot of great activity happening. Do check out the forums, the newsletter, and stay tuned for our next course. Thank you and goodbye.